Okay, this is part two of learning unit one, chemical foundation. We'll start off with elements first. Okay, so if you have time, you might want to grab a periodic table. Element is a fundamental building blocks, and then basically it's just like alphabet, A, B, C, D. When you put the alphabet together, it forms a word, right? An element, when you put the elements, different elements together, it produces compound. Now, if you look at the periodic table, you can see that each element has its own symbol, and some of the symbols are a little bit interesting in terms of like, a symbol. For example, like gold, the symbol is AU. It doesn't have any G in the symbol simply because gold is an older element, and it derived from this word arum. Arum means shining dawn, so it is a Latin word. Okay, so that's why we just use the AU from arum. Lead is also a Latin, derived from this Latin word plumbum. Okay, plumbum means heavy, so that's why lead has PB. Chlorine is derived from this Greek word, which describes the color of chlorine gas. This is the overview of the periodic table. You can see that each element has its own symbol. Some of them has two letters, some of them has one. So if you have an element with two letters, you want to make sure that the first letter is capitalized and the second one is not. Okay, so you can see like something like titanium here. Titanium, the symbol Ti, and only T that is capitalized. Now let's take a look into the atom of each element. Dalton, okay, Dalton was the first person who looked into this. He he came up with this theory. He said the elements are made of tiny particles called atoms. All atoms of given elements are identical, and you can see that I can kind of circle this, which means that right now this is not true. Not all atoms in one element are the same. You will see why later on. And then the third one here, the atom of given elements are different from those other. Of course, it's true because the atoms of gold is going to be different from the atoms of silver. Now, the atoms of one element can combine with an atoms of another element to form a compound. Okay, let's think about it. You have an atom, the hydrogen, atom of hydrogen, and then you have the atom of oxygen, right? And then you combine them together and becomes compound, just like that. The last one, number five, the atoms are indivisible by chemical process. That means that atom is the smallest particle, and then within the atoms there are subatomic particles, which we will talk about today. Okay. Now, the structure atom. Let's take a look inside the atom. Okay, so the first person who looked into that is called J.J. Thomson. And what he did, he discovered the electron. Okay, and then he knows that, well, if you have an atom which is neutral, if you have a negative charge, that means that you also have to have the positive charge to balance out the negative charge, right? So he basically, Thomson discovered the electron, and he also discovered the positive charge, which is called the proton. So William Thomson came up with a model, which is he called the plum pudding model, because it does look like a plum pudding here. So basically, what we have is we have the electrons which carry the negative charge are kind of embedded in this dough of the positive charge. So basically, you can see that it looks very similar to plum pudding. The electrons are the plum. Yeah. Now, Rutherford. Rutherford went in and then looked into the plum pudding model, and he came up with this device, and he want to um, look into try to prove that this plum pudding model is true. So his device composed of something called the source of alpha particle. Alpha particle, remember, it has positive charge, okay? And then this beam of positive charge going shoot through this very thin gold foil. The gold foil is so thin, it composed of like only one or two layers of gold atoms. And now, if Thomson plum pudding model is correct, you the positive beam should be shooting right through the atoms. It should deflect slightly, okay, because this is a sphere of positive charge. It is not condensed. It's just a sphere of positive charge. And what he found is something that's different, because he found that most of the alpha particle, the positive charge, just went right through. And then every now and then he would see some that scattered, okay, slightly deflected, okay. And then once in a great while, he would observe that the alpha particle deflected almost right back at him. So now, from based on this, he was like, "What is going on?" Because if this model is correct, you should not be seeing something like this. So Rutherford came up with another model. His model looks something like this. You know, instead of having this scattered positive sphere, he kind of condensed everything and then put it right in the middle, and he called it nucleus. So nucleus is basically is a condensed positive charge, and around nucleus you will have the electron that's kind of floating around. Essentially, the atom is just full of empty space. Right in the middle is where you find the protons with the, that condensed positive charge. Here is another picture of the atoms. You have the nucleus that has proton, neutrons, and then around it are the electrons that kind of floating around, circulating around the nucleus. Okay. Now I mentioned neutron. Okay. Neutron is another subatomic particle that was discovered later. And as it is neutron. Neutron basically it does not have any charge. Electron carries one negative, proton carry one positive. Neutron does not have any charge. Now let's take a look at the mass. Okay, so you can see that electron. Okay, what we're doing is that it is kind of difficult to compare the mass by just looking the actual mass, because the number doesn't look too pretty. So what we're going to do is that we're going to set the mass of the electron to be 1. Okay, and then we're going to do this relative mass. What we found is that proton is about 1,800 times heavier than the electron. Neutron too. Neutron has the mass that is about 1,800 times heavier than the electron. And as you can see here, if you put all of this together, electron, proton, neutron, you can see that the mass of the atom mainly come from these two subatomic particles, the proton and the neutron. Okay. So now, when you have those subatomic particle, how are we going to represent this? We represent this by using something called atomic notation. And you can see here, X. X basically it is a symbol of element. For example, lithium, Li, right? And then upper left hand corner is the mass of that atom, and then lower left hand corner is the atomic number. Basically, it represents the number of proton. When you look at the periodic table, you can see that lithium is number 3, right, on the periodic table. That means that lithium has 3 protons. Now, if you look at the periodic table right now, look at it right now, you can see that each element has its own number of protons. When you change the number of protons, you are going to change the element. So lithium will always have 3 protons. Now, because we know that the mass of an atom composed of mainly come from the proton plus neutron. So if you have the mass of 7 and you know that the proton is 3, so that means that the neutron has to be 4, just like that. Okay. So let's take a look at this really quickly. Okay, so we have um, helium. Okay, He is helium. You can write this down. Okay, and then the number of proton is 2. Now, because it's a neutral atom, if you have 2 positive, you have to have 2 negative. Now, number of neutron, 4, subtract 2 is 2, and then the atomic mass is 4. Okay, so iron, okay, iron Fe, okay, and if you look in the periodic table, you can see that Fe has 26 protons. So you write down 26 over here. Now, because the neutron is 30, 30 plus 26, so that is 56. Okay, so if you have 26 protons, you will have 26 electrons as well. The atomic mass will be 56. Chromium, okay, chromium, the symbol is Cr. And then chromium is element number 24. And then if the mass is 52, this is 24 electrons, 24 protons. So that means that uh, 52 number of neutrons will be 52 subtract 26. So, oh, I'm sorry, 52 subtract 24, that would be 28. Okay. Now, what about this one? 53. Let's take a look at periodic table. Element 53. Let's scroll down. 53 looks like it is iodine. Okay. So we write I, and then 53, number of protons, mass 127, and then electron will be 53 as well. And then 127 subtract 53. So that means the number of neutrons will be 74. Okay, so that's how you do it. Okay, so now remember when we talk about Dalton's atomic theory at the beginning, I said that, well, number 2 is not quite right because he said that the atoms, all the atoms in the same element will all be identical. What we found that is not true simply because of something that is called isotope. So isotope are different forms uh, of the same element. Okay, you know what? Let's take a look here. Let me show this picture to you. You can see that this is hydrogen, has 1 proton. Hydrogen, because it has 1 proton. This is hydrogen, it has 1 proton, right? And then also it still have 1 electron. But the difference is that deuterium has 1 neutron, and then tritium has 2 neutrons. You can see that, right? So basically, it is the same element. It has the same number of protons, but the difference is that they have different number. Within these 3 isotopes, they all have different number of neutrons. So this is what we call the isotope. They are isotope to one another. It is a relationship. Okay. All right. This is the end of Unit 2. I think you can, if you understand, you can, give it a try. Do homework number 2. All right. Thank you.